Right, in this video I'm going to talk about the least common multiple abbreviated by the letters LCM. So the least common multiple or LCM of two numbers is the smallest number that can be divided by both numbers giving no remainder or zero remainder. Now there's a number of methods to work out the LCM, and that is the beauty behind mathematics, but I'm going to go through two of the methods. And here's an example to illustrate the method of listing. So example number 1, find the least common multiple or LCM of 6 and 15. So let me explain working out the LCM using this method of listing. Now by listing I mean listing the multiples of the numbers concerned, and the smallest number which is common to both of these multiples will therefore be the LCM. So here is the method. So in step number 1 we write down the multiples of 6. So multiples of 6, or if you go through the 6 times table, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. Or you can just as well add 6 continuously to get the multiples of 6. Then do the same with 15. So write down the multiples of 15. That is the second step, step 2. Or if you're unaware of the 15 times table, you can add 15 each and every time. So 15 times 1 is 15, adding a 15 to that is 30, adding a 15 to 30, 45, adding a 15 to 45, 60, and so on and so on. And then in the next step, or in the last step, what you need to do is you need to identify the smallest number which is common to both of these lists. So the smallest number, as you can see, is 30. So 30 is the smallest number which is common to both multiples of 6 and 15. So in step number 3, the smallest number which is in both the multiples of 6 as well as 15 is 30. So therefore 30 is the LCM of 6 and 15. So you could also write in this form, you could say that the LCM of 6 and 15, so of 6 and 15 is 30. And then you're done. Right, let's have a look at another example. So example 2, find the least common multiple or LCM of 3 and 15. So let's have a go at this one. So in step number 1, write down the multiples of 3. So multiples of 3. So let's go through the 3 times table. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, and you don't need to continue. You can stick with a certain amount of multiples, because when we go through the final step, one of these may be common to both sets of multiples. So let's just stick there for now. And in the second step, do the same with 15. So write down the multiples of 15. So in step number 2, multiples of 15. So if you're not aware of the 15 times table, again you could add 15 each and every time. So 15 plus 15, 30, 30 plus 15, 45, 45 plus 15 is 60, and so on and so on. And in the final step, identify the smallest or the least number which is common to both sets of multiples. So as you can see, the smallest number or the least number which is common to both is 15. So in this case, if I revert to the blue pen, I could say in the last step that the LCM, and it's the LCM of 3 and 15, so of 3 and 15, and that is 15. And then you're done. Right, let's have a look at this one. Example 3. Find the least common multiple or LCM of 4 and 7. So in step number 1, let's write down the multiples. So multiples of 4. So going through the 4 times table, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8, 32. But let's stop there for now. And let's do the same with 7. So multiples of 7. So going through the 7 times table, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5, 35. Let's stop there for now. And in the last step, step number 3, so step number 3 is the step whereby we identify the smallest or the least number which is common to both of these lists. So the smallest number or the least number which is common to both is 28. So if I go back to my blue pen, we can say that the LCM or the least common multiple, so the LCM of, in this case, 4 and 7, so of 4 and 7 is 28. And we're done. Right. Now, there's another way to work out the LCM or the least common multiple, and this is by using the method of repeated division. Now, we know the LCM of 6 and 15, so using the method of listing, so if I go up to our previous example, the LCM of 6 and 15 we know as being 30, so 30 is the LCM of 6 and 15. Let me make a note of that over here. And let me show you that we're going to get 30 using this method number 2 as I'm calling it. And method number 2 is using a method of repeated division. Now by repeated division, we're dividing these two numbers repeatedly by prime numbers. Now what do I mean by prime numbers? So let me remind you. So prime numbers are basically numbers which can be divided by itself and 1. So for example, 2's a prime number, 3's a prime number, 5's a prime number, 7 is a prime number, 11 is the next prime number, and so on and so on. But I'm going to stop with 7 for now. Okay, so you don't need to continue. This list of prime numbers is more than enough for this method of repeated division. Okay, and the idea being, so we write the 6 and 15. So we need to work out the LCM of 6 and 15. So write the 6 and 15. And first try to divide by 2. Okay, so we need to check whether both of these numbers can be divided by 2, giving no remainder. So that's the most important point. So first go through the list and check whether the numbers concerned, so both of these numbers, not only one, both of them, can be divided by one of these primes, giving no remainder. Okay, and we continue this process until we can no longer divide the resulting numbers, or if the resulting numbers, okay, are prime numbers or contain a 1. So let me go through this example just to explain this point. So I first check 2. So 2 occurs first. I first check 2. 6 divided by 2 is 3, no remainder. But 15 can't be divided by 2 because 15 divided by 2 gives us a remainder. Okay, so 2 wouldn't work here. So let me just emphasize with a cross. Then I check 3. 6 divided by 3 gives us 2 with 0 remainder. And 15, it can be divided by 3, giving us 5 with no remainder. So 3 works. So as I said, 6 divided by 3 is 2, 15 divided by 3, 5. Okay, so 3 works. Let me just emphasize that with a tick. And then we stop the process because these two numbers, 2 and 5, are part of this set of prime numbers. Okay, even if you have a 1 with a prime number, stop the process. Or even if you cannot divide the initial set of numbers by the prime numbers concerned, stop the process. So over here we have prime numbers of 2 and 5, so we stop the process. So we say that the LCM of 6 and 15, and what we need to do with these numbers is we need to multiply. So we multiply the 3 by the 2 by the 5. So if I revert to the blue pen, so the LCM in this case will be 3 multiplied by the 2 multiplied by this 5 is 30. So 30 being the LCM of 6 and 15. So just to reiterate, so you keep on dividing by prime numbers, okay, until the numbers right at the end are either prime numbers or contain a 1 together with a prime number. Okay, right, let's do the same with 3 and 15. So let's go through this process. So first what I do is I list the prime numbers 2, 3, 5, 7. This is more than enough, so you don't need to write down the other prime numbers. So this is more than enough until 7. And then I write down 3 and 15. And I first check whether I can divide these numbers by 2 and whether it's the case that if I divide by 2 I get no remainder. So 3 divided by 2, that cannot be done. 15 divided by 2, that cannot be done. Let's check 3 then. 3 divided by 3 is 1, no remainder. 15 divided by 3 is 5, no remainder. So if I divide by 3, 3 divided by 3 is 1, no remainder. 15 divided by 3 is 5, no remainder. Okay, and as you can see, I have a 1 and a prime number. So if you either have 2 prime numbers here, or if you've got 1 with prime numbers, stop the process. So just stop the process. And what you need to do is you need to write down that the LCM of 3 and 15. And remember the idea being we multiply these numbers, the 3 by the 1 by the 5. So if I revert to the blue pen, 3 times 1 times 5, 3 times 1 is 3, times 5, 15. So 15 is the LCM of 3 and 15. Right, let's have a look at one more. Find the least common multiple or LCM of 4 and 7. So first write down the prime numbers 2, 3, 5 and 7. Again, this is more than enough. Write down 4 and 7. And let's go through this list, starting with the 2. 4 divided by 2 is 2, no remainder. But 7 divided by 2 doesn't work. Let's check 3. 4 divided by 3 doesn't work. 7 divided by 3 doesn't work. Let's check 5. 4 divided by 5 doesn't work. 7 divided by 5 doesn't work. So if you divide by these numbers, it gives a remainder. Okay, so we need to find a number, remember, such that when we divide it, it gives no remainder. So 2, 3, 5 don't work. Let's check 7. 4 divided by 7 doesn't work. 7 divided by 7 is 1. It needs to be divisible, or it needs to be divided by both, giving no remainder. So 7 doesn't work, and there isn't any point going to the next prime number, because the next one is going to be bigger than these two, okay, and therefore it wouldn't be divisible, or you wouldn't be able to divide these numbers by the next one, as it would give you a remainder. Okay, so stop the process there, and you say that the LCM of 4 and 7 in this case, and all you do now is just multiply these two. So if I multiply these two, so multiplying the 7 and the 4, so let's have a look. Let me revert to blue. 4 times 7, that is 28, and then you're done. So remember, if you can't divide by these numbers on your list, or if you can't divide all together, stop the process and just multiply these two numbers. Okay, so if you multiply these two numbers, that will therefore give you the LCM. However, let's continue. So I've got another one. Now, pause the video, have a go at example number 4, see how you get on, and I'll go through the solution soon. Right, example number 4. Find the least common multiple, or LCM, of 24 and 36. So let's use this method of repeated division. So first as ever, let me write down the list of prime numbers 2, 3, 5, 7, and as I said before, that's more than enough. And we're going to work out the LCM of 24 and 36. So let's check whether we can divide both of these by 2, giving us no remainder. So 24 divided by 2 is 12, no remainder. 36 divided by 2 is 18, no remainder. So 2 works. So divided by 2, 24 over 2 is 12, no remainder. 36 divided by 2 is 18, no remainder. Now let's check whether we can divide both of these by 2 again. So 12 divided by 2 is 6, no remainder. 18 divided by 2 is 9, no remainder. So we could repeat with the 2. So divided by 2 again, we had 6 and 9. Let's check 2 again. So 6 divided by 2 is 3, no remainder. However, 9 can't be divided by 2, so 9 divided by 2 gives us a remainder, so 2 doesn't work. So let's go down the list, let's check 3 instead. 6 divided by 3 is 2, no remainder. 9 divided by 3 is 3, no remainder. So 3 works, so divided by 3, 6 divided by 3 again is 2, 9 divided by 3 is 3. And we stop there, remember, so these two are part of the prime numbers list, so we stop there and we say that the LCM of 24 and 36, and remember the idea from here on, we need to multiply the 2 by the 2 by the 3 by the 2 by the 3 again. So we multiply these numbers here. So if I go back to the blue coloured pen, so we're multiplying 2 by this 2 by this 3 by this 2 by this 3 again. Whoops, let me be as neat as I can. So that should be a 3. So 2 times 2 is 4. 4 times 3 is 12, 12 times 2 is 24, 24 times 3, 72. So 72 being the LCM of 24 and 36. Right. Pause the video, have a go at example number 5. So you need to find the least common multiple, or LCM, of 12 and 20. So pause the video, have a go, see how you go, and I'll go through the solution very soon. Right, let's have a look at example number 5 using the method of repeated division. So let me write down the prime number list over here, and we need the LCM of 12 and 20. So let's check whether these two can be divided by 2. 12 divided by 2 is 6, no remainder. 20 divided by 2 is 10, no remainder. So 2 works. So 12 divided by 2 again is 6. 20 divided by 2 is 10. Let's check whether 2 is possible again. So 6 divided by 2 is 3, no remainder. 10 divided by 2 is 5, no remainder. So 2 works again. So we have 3, we have 5. And remember the idea, we stop here because 3 and 5 are part of the prime numbers. So we stop there, and let me get my red pen ready, so that in the last step we're multiplying the 2 by this 2 by this 3 by this 5. So here's the last step. So let's write down the LCM. So the LCM of 12 and 20. So let's multiply this 2 by this 2 by this 3. Whoops, so by this 3 by this 5. So 2 times 2 is 4. 4 times 3 is 12. 12 times 5, 60. And then we're done. So 60 being the LCM of 12 and 20. Right, and that is it with the examples. So I hope you enjoyed this video. I hope you liked this video. If you did enjoy the video, be sure to like and subscribe, and I hope to see you for the next video. Thank you.